In my own words, the React mental model, the story that will continue is like a suspense thriller. I will uncover it because I learn like Feynman, a Nobel Prize-winning physicist. I learn visually. I always have blank sheets of paper on my table and try to draw what I learn. I have to have a clear vision of it based on first principles. I don't memorize scripts. I always go back until I reach what I still understand, and from there I go forward again and again and again until every card sits in its place. Then I know that subject for the rest of my life. Now, I used ChatGPT by prompting questions, but I never received the final answer on the first attempt. Maybe it came hours later, after many of my statements. It is important, not question, but my statements, and many disagreements with ChatGPT. That conversation flowed between me, who programmed in Fortran in 1969, and who has continuously learned and taught programming languages ever since. For the last 36 years, I have mostly worked in web development. During the last 4 years, I have been learning React and have been very confused. Why? Because I thought I knew all the first principles of React, but I did not. Now, in this story about the React mental model, I had a big aha moment. It happened when I started comparing vanilla JavaScript, React, and Vue in the same application. Then I discovered new first principle, especially for JavaScript and all modern JavaScript libraries. I rediscovered vanilla JavaScript, in which I had programmed extensively almost 30 years ago. Here is my learning path to that aha moment. It is concise recap of many brainstorming sessions between ChatGPT and me. Let's begin the story about the React mental model. What happened immediately after React application was called? Immediately after React application is called, HTTP finds the location of the React application on the Node server and starts loading the traditional homepage index.html. The browser parses index.html and builds the DOM. What is parsing? Parsing is the process in which a browser uses the hierarchy of an HTML document to create 3 nodes. Every node is one HTML element. HTML elements are related to one another as parents and children. What is a DOM? DOM is the acronym for Document Object Model. It is 3 of nodes. Every node is one HTML element. A browser creates the DOM from an HTML document. What happened after the DOM had been created? After the DOM has been created, at the end of index.html, the browser calls the script. This script loads the JavaScript file index.js. In this case, it is the entry point of the React application. What happens when index.js is called? The browser loads React like any vanilla JavaScript application. It loads it into the JavaScript engine. The only difference is that React is written in JS6. The browser must first convert JS6 into vanilla JavaScript. Then the vanilla JavaScript goes to the JavaScript engine. What is the JavaScript engine or virtual machine? High-level programming languages, which are almost like the English language, were invented to improve people's productivity. At the same time, nothing changes in machine language, which consists of bits, ones and zero in hardware. One is approximately 5 volts and 0 is 0 volts. Today, 64 lines of the bus carry these electrical signals to the microprocessor. 64 bits, each either 5 volts or 0 volts, switch billions of transistors on and off inside the microprocessor or central processing unit. Only machine language can do this. At first, people wrote machine language directly. Then, they invented assembly language as a small step toward higher productivity. Today, C is one of the closest practical languages to assembly and is widely used for IoT, Internet of Things. People wrote programs in assembly language, which we call assemblers. Different processor families have different instruction sets, so every processor family has its own assembly language. Programs that translate high-level languages, such as JavaScript, into machine language are called compilers. There are people whose job is to write compilers. Not everyone in the world writes web applications. Writing a compiler from high-level language to assembly language is an enormous task. The assembler then converts the assembly language into machine language. We need the compiler only to generate assembly language. Writing a complete compiler from a high-level language directly to machine language for every processor architecture would be impossible because there are so many different processors and assembly languages. We need only one common compiler for about 80% of the work. The last 20% can be written separately for each processor architecture. It is much less work to write different versions of the last 20% than to write the whole compiler again for every processor. That common 80% is known as the virtual machine or the JavaScript engine in the case of JavaScript. It is almost the same in all modern JavaScript engines, such as Google's V8, Chrome and Edge, Mozilla's SpiderMonkey, Firefox, Apple's JavaScript Core, Safari, and the Chakra, which was used in older versions of Internet Explorer and Microsoft Edge. It is almost the same as it was in 1995 in the first version. The biggest changes happened after 2015 with features such as let and constant, arrow, functions, classes, template, literals, destructuring, the spread and REST operators, modules, import and export, promises, asynchron await, default parameters, and many other features that gave modern JavaScript libraries and frameworks new possibilities. Why is this first principle important in the story about React? It became important when I finally opened my eyes and saw that React syntax has very little in common with vanilla JavaScript. React has many new terms that vanilla JavaScript does not have. React has many new terms that don't exist in vanilla JavaScript. Examples include on-click, on-change, on-submit, on-key down, on-mouse enter, on-mouse leave, useState, useEffect, useRef, useContext, props, state, children, fragment, and JSX itself. React JSX is transformed into JavaScript and then goes to the JavaScript engine. But what about all those new React keywords? Do they require changes to the JavaScript engine? React is updated every 6 months. Other modern libraries are updated as well. Does that mean the JavaScript engine has to be constantly refactored? Here came the rare moment when AI immediately gave me the final correct answer. No. React solves this through its own API. It is excellent first principle for React. React solves this through its own API. Does that API work at the beginning when JSX is converted before entering the JavaScript engine? No. The API processes React features only when their execution time comes inside of a virtual machine. The authors of React wrote that API. The API translates React's terms into ordinary vanilla JavaScript, which is then executed instead of those React terms. How simple the solution is. I will read that story continued, but in this moment I would to say that all the story about React API is similar to story about advanced languages and machine languages. Every advanced languages must finish in machine languages. So here, everything in modern libraries and frameworks must finish in vanilla JavaScript. JavaScript engine processes vanilla and only vanilla JavaScript. But that solution that we can build and adding any terms to make more productivity for us. In React, Svelte, Vue, Solid.js, and any libraries, it is a reason why that libraries update every 6 months. Maybe we see updates of JavaScript, vanilla JavaScript every year, but it is really something cosmetic, not revolutionary. Because we don't need it. As we don't need, but we cannot change machine language. We know reason. We can make changes richer and richer in new terms, libraries, and we can change this in advanced language. But we don't change vanilla JavaScript. I use vanilla JavaScript here very often. Vanilla just as not only JavaScript, because in a story in education of React, we say React is a library of JavaScript. All other libraries is libraries of JavaScript. But when you start to learn React and look at you don't see that libraries. It is complete new syntax, new terms, and where is JavaScript inside of it? And very often from that kind of education, students think that vanilla is something past. It is something what was used 30 years ago. But no, vanilla JavaScript is all today. Every library, every framework is vanilla JavaScript. Because would be translate by open API during process in JavaScript engine will be convert by API, open API in vanilla. And in the end, in JavaScript engine or virtual machine, every library became vanilla JavaScript. Okay, thank you for watching this video. If you know somebody that needs video like this, tell them about. If you like it, like it. If you need, subscribe to it. Once more, thank you for watching this video.